Introduction to integers. Okay,
What?
so we did whole numbers last time, right?
Right.
And we were just playing around with whole numbers, which, first of all, is built on natural numbers. Okay, so natural numbers, one, two, three, four,
Then
five.
you throw in the zero,
Oh, don't forget the zero.
you get the whole numbers.
You throw zero in there, now you have whole numbers, right? So whole numbers is its own thing, whatever. Well, then towards the end of that, we decided to take some whole numbers and start subtracting them, that operation on top of the whole numbers. And we found out that if we subtract a number that's bigger than the whole number we started with, kind of like 4 minus, that's not a 4, try that
It's
again,
close.
4 minus 5, you end up with
Negative.
a negative, right? So you end up in the negative realm. That's the integers, okay? Integers symbolized with the symbol z to represent the integers. Why is it a z?
Oh, well, okay, so it comes from the German word Zahlen, Zahlen, and it basically means numbers in German. So there you go.
So the Germans, a very
Astute people.
smart group of
Although I
people.
don't think it was a German who actually said it. I think it was just a dude who took the word for German from the Germans.
All right. Well, that sounds like fun.
I'm just so the people who actually came up with it. So the idea of a negative number, so the negation idea, was actually first introduced around 600 AD by Brahmagupta. So he was the first one who gets credit for it. So he was the first one in the books. But the idea of a negative idea comes from just businesses. So like all civilizations had this monetary prospect where they had to get money from people, taxes and all that good stuff. The Chinese had a system of a red dot. So anytime they used a red dot, it means that they had that somebody owed money to them. Uh, in the 1500s, there sort of became the system of numbers that we sort of call the integers, and then it was finally accepted the idea of integers in the 19th century, so 1800s. So that's not that far away from us. So
That's really recent, actually.
relatively new,
Fantastic. That's terrifying.
right?
So how do we interpret the negative sign? There's different ways to think about it that helps us to work through our problems, to navigate. Of course, we all know negative, right?
Right.
I like to think of negation
Negation, opposite.
and opposite. Fancy no, no. So negative, negation, and opposite. So if you consider those words, yeah, if you consider those words, you will see like navigating through the problems is a little bit easier, at least thinking through what the words and what the problems are saying.
Correct.
Okay, so let's get to some problems. So 3 plus 4, let's go with our dots. All right, we'll use a regular black circle to represent three objects. Okay, and we're going to have four additional objects combined with that. Now we're looking at a total of 7 objects altogether. That's very boring. Okay, let's say we have 1, 2, 3, 4, and I don't want to talk about taking things away anymore. I want to talk about negations. Okay, I want to negate 1, 2, 3 of these 4 circles, and you'll see that that leaves me with only one, right? One little circle left. So 4 minus 3 is 1. That's not something that we've thought, well, maybe we've thought about it, but we don't think about it in the problem, usually while working out the problems. We're just trying to do 4 minus 3. We know that's 1. We don't spend a lot of time thinking about it. But that's what's going on. Let's extend that idea to 3 minus 4 now. Okay, I have 1, 2, 3 objects, and I want to negate 4. So 1, 2, 3, 4, right? Well, if I'm introducing 4 negations, that's going to leave me
It's an
with
extra one.
an extra negation. Now I'm in the negatives, right? So that would be a -1.
Way to go, Chinese red dot.
The red dot Chinese, right? And then -3. All right, I'm starting off with 3 negations. And then I am going to negate 4 on top of that. What? I'm just throwing negations on top of negations. I'm just adding together a bunch of negatives. I'm now at -7. Okay, so there you go. That's the what's happening there. I think we should generalize those rules because we don't want to think like this
Every time.
every
No,
time
that's
we
way.
do a problem, right? So let's generalize some rules. So basically, the signs are the same. You're dealing with two positives or two negative numbers. You add them together and keep their sign, right? Let's look back at that real quick. That would be this one right here, negative 3 minus 4, and that would be 3 plus 4, right? In this case, we have two positives, add together, positive 7. This one here, two negatives, add them together, 3 plus 4 is 7, negative 7, because they're both negative. All right, if the signs are opposite, I'm going to subtract the values and keep the sign of the bigger number. So,
Well, bigger. So in essence, not really bigger,
you notice the quotation marks,
yeah.
right?
So, right, because when we talk about bigger, we're looking at I don't know how would you go with the magnitude or the idea of like
Magnitude.
the magnitude. So when we discuss this, all negative numbers will always be smaller than a positive number, no matter what. No matter how small the positive number is, every number negative is going to be less than that value.
Yeah.
But when we do this opposite sign rule, we're thinking about the magnitude. So what the number looks like if it didn't have the negative there.
Yeah, it's like which one's going to win. That's kind of how I look at it, right? So like if we look at where are we?
The 4 minus 3
Yeah,
and 3 minus
3 minus 4. 3 minus 4, I'm looking at that as I have a positive 3 and a negative 4. The negative 4 is bigger in the sense that if those two ran up against each other, negative 4 would win, and you would end up with a negative result. So yeah, that's what I'm saying. And then 4 minus 3 up here, the 4 is bigger than the 3. The positive number is bigger, so the positive would win if they combined. So that's what I mean by bigger number. It's true that any number that's positive is going to be greater than any number that's negative. Okay. I think that's all we got to say about that.
Good.
Okay, let's talk about double sign. So this only really pops up if you're trying to work through a problem like you're substituting a number in. Okay, we're not doing that just quite yet, but in case that were to happen in the future, this is how we can handle it. Okay, and I like to think about it in terms of opposites and negatives, right? So the first one's easy. 10 plus positive 4 is the same thing as I'm just adding 4, right? This means the same thing. 10 plus positive 4, that's what this means. So that's 14. No issues there. If I'm adding a negative 4, I am adding the negation, right? I am taking away, well, not taking away, I'm adding the negatives in, right? So if you're introducing negatives, you're really subtracting. Okay, so 10 minus 4 is going to give me 6. All right. 10 minus 4, 10 minus positive 4, I say that is 10 and the opposite of positive 4. The opposite of positive 4 is negative 4, which would be 6, or 10 minus 4 is 6. And then the opposite of negative 4, 10 opposite of negative 4 is a positive 4. 10 plus 4 is 14, right? So this is similar to the last rule we looked at, right? When the symbols are the same, right? So we have positive, positive, that translated into a plus sign. Negative, negative, or minus a negative, translated into a plus sign. When I had different signs, that translated into subtraction. Okay, so same signs, positive, different signs, negative. Okay, let's get to multiplication. Now let's go back to our dots here, our circles. All right, 3 times 4 means I have 3 groups of 4. All right, so we can see that. 1, 2, 3. I have 3 groups of 4.
Which gives us a total of 12.
We have 12 dots, 12 circles, okay? I want now the opposite of 3 groups of positive 4. Okay, so let me say that again. So I have 3 groups of 4. And I'm going to use a red box to indicate I'm doing the opposite. So I want the opposite of 3 groups of 4.
So we negate.
So that's going to be, all right, I should say the opposite of 3 groups of positive 4, which would be 3 groups of negative 4. So that's going to be negative 12. Okay, so negative 3 times 4 is negative 12. Similarly, if I want 3 groups of negative 4, okay, well, I can draw 3 groups of negative 4. Okay, and we box them in. There's my 3 groups. That's going to give me negative 12 once again, right? Because I have 12 red circles. And then I want the opposite of 3 groups of negative 4. All right, so let me just start off with 3 groups of negative 4. And I want the opposite of those. So the opposite of 3 groups of -4 is going to be 3 groups of +4, which is a +12. Okay, so again, that's a nightmare to think through every time. Don't do that. Instead, we'll just go ahead and generalize these rules, right? When we multiplied sign or 2 numbers with the same sign, so 2 positives or 2 negatives, they both resulted in a positive answer. When I multiply 2 different signed numbers, -3 times 4 or 3 times -4, a positive and a negative, both times I resulted with a negative answer. Okay, so general rule, same sign will give you a positive, opposite signs will give you a negative. All right.
Division?
Let's go to division. Okay, let's draw some pictures again. So we got 12 objects. And I want to know if I broke this up into groups or into 3 total groups, what do I have in a single group?
4 black dots or circles.
Yeah, there we go. So 4. That's easy. We know that one. Okay. What if I had 12 red circles, right? 12 negatives. And I broke that up into 3 equal-sized groups.
4 red circles.
So that will be a -4. Okay, I don't think those are too difficult. This is where it gets a little tricky. 12 divided by -3. Okay, so I'm starting off with 12. And again, I want to break this up into the opposite, right? So 3 equal-sized groups,
but the negation
with the opposite sign. All right, and if I do that, of course, that's going to give me 3 red circles, right? That's the opposite of 4. I'm sorry, 4.
Yeah.
4 red circles. That's the opposite of 4 black circles. So -4. Okay, well, what if I have 4 red circles to begin with? 12 red circles to begin with. I'm not good at numbers.
It's cool.
Yeah. And I want the opposite
of each group.
Or what's in a single group, right?
Yes.
The opposite. So that would be 4 black circles. +4. Right? So again, let's generalize those rules. Maybe you notice, right? Maybe you're brilliant and you noticed, well, look, positive and positive gave me a positive. Negative and positive gave me a negative. So same sign, positive, different signs, negative. Is that true? Different signs, negative. Same sign, positive. Okay, turns out, yeah, it's the same exact rules. So I wrote this as a separate, a separate line, but you could put multiplication here as well. So multiplication and division, same thing, same rules.
Yeah.
All right. A couple more problems. Let's do some more division. So 6 divided by 3. All right. Well, I got 2, right? That's +6 divided by +3 is 2, and it's positive, so there we go. -6 divided by 2.
Negative.
Well, 6 divided by 2 is 3, and negative and positive is negative. Cool. 3 divided by -1. Well, 3 divided by 1 is 3, and positive and negative, so negative. -1 divided by -3. Okay, negative is positive, and I have this new number.
Not an integer.
Oh no. Guess what? Tune in next time for